Hey, and welcome to 8.7 today. Today we're going to be graphing sine and cosine waves using some special features that we've learned about, like a period and an amplitude. These are two different characteristics that are going to make graphing these trig functions a lot easier. The period is over which span it takes that wave to repeat. So with a sine wave, how long does it take before it gets back to its starting point? And then it basically repeats itself indefinitely after that. The amplitude is how high or how low does the graph get. You could look at it as over what interval is the range of this function. So we're going to be using those two features to graph both sine and cosine. Let's get started. Okay, so let's start today with 8.7. 8.7 is going to be using features to graph trig waves. And this is the last part of the unit circle that we're going to be covering in this course. So there's two features that we're going to be using. The first feature we're going to be using is what we call a period. And the period is the interval over which the wave completes one circuit before repeating. So it's the interval over which the wave completes one circuit before repeating. And we're going to look at those for the three trig functions that we have. We're going to look at that for a sine wave, a cosine wave, and a tangent wave. And albeit we're only going to be graphing sine and cosine today, we're still going to write down the generalized rules for tangents just for future lessons. So let's take a look at what they were originally. So the original period of a sine wave before the sine wave repeats itself is going to be every 2 pi radians, or every 360 degrees that sine wave loops. Same thing with cosine. It's every 360 degrees or every 2 pi radians. Tangent is a little faster than that. It's going to be every pi. And now what we're going to realize is that we're going to be modifying these throughout this lesson. Let's take a quick look at how these three things are going to be valued. It's going to be y equals a times whatever trig function, so sine, cosine, or tangent, of bx. So we're going to say this trig function is going to be replaced with sine, cosine, or tangent. So a sine bx, a cosine bx, or a tangent bx. And we're going to take this and we're going to say what normally was 2 pi is going to be 2 pi divided by whatever that b is. And that's going to be the period over which the sine wave repeats itself. Same thing with cosine. It's going to be every 2 pi over b. Tangent's going to be the same thing. Except for instead of being 2 pi, it's just going to be pi over b. And that's the period of which the graph repeats itself. The second thing we're going to look at is going to be the amplitude. And now the amplitude is going to be the height of the wave given as a distance from the midline. Okay, so normally what we would look at with the height of a wave is most of us would associate with the waves that we would see every day. Like, let's look at the ocean. So we would say, okay, I know the ocean, part of my drawing, is going to be something like this. And we're going to say, hey, what is the height of that wave? We're going to go from the bottom to the top. And that's the way most of us would measure that, correct? Well, that's not going to be the case here. What we're going to do is we're going to measure the height of the wave from the midline. That means that if we have a graph, let's take a sine graph. So it's going to start here, and it's going to go up, it's going to go down, and it's going to come back up. The midline is the middle of this graph. So my midline is right here. And the amplitude is going to be the distance from that midline to the crest or the top. and the midline to the bottom or the trough. Both of these are going to be equal, and they're going to be our amplitude. And that's going to be what we measure. So let's take a look at those three trig values again. Let's take a look at sine, cosine, and tangent. And now the amplitude, these are very easy. Amplitude normally would be a 1. Normally would be a 1. It goes up to 1 and down to 1, or up to 1 and down to -1, up to 1 and down to -1. Tangent we know goes up to infinity and down to infinity. So tangent, this is going to be, doesn't have an amplitude. If you really want to be technical, you could say the amplitude is equal to infinity, but we're just going to say that tangent generally does not have an amplitude, unless you're going to call it infinity. So let's take a look at how those are modified. Well, because it's a 1, it's going to be 1 times this a value. So we're just going to call it a, whatever the number is out front. Same thing with cosine. It's going to be whatever the number is out front. And so knowing what a period is and what an amplitude is, let's go ahead and let's label them on some of these graphs. Okay, so for this part of the worksheet, what we're going to be doing is we're going to be stating the amplitude and the period and giving the equation that represents this graph. So visually is going to be how we attack this first. Now, we know with the period, we're going to be saying, hey, for sine or cosine, it's going to be 2 pi over the b value. And because we're not dealing with tangents, that's all we're going to be worrying about. For the amplitude, we're just going to be dealing with the a value. So let's take a look. The period of which this graph repeats itself. So if we start right here in the middle, we know first off this graph is going to be a sine graph. So it's going to be y equals something sine something x. And so when does the graph come up to this point again? Well, right here. And that's going to be every pi. So I know somehow 2 pi divided by b ends up being equal to pi. And I just need to figure out what this b is. So what I'm going to do is I'm going to cross multiply, and I'm going to get, actually I'm going to write this over here. Give us some room. I'm going to get a 2 pi equals b pi, divide both sides by pi, and my b is equal to 2. So I know that this is a 2. The amplitude's even easier. I just look and see how high does this graph go and how low does it go. Well, it goes up to 3 and down to -3, which means it's going to be 3 sine of 2x. And that's it. Let's take a look at the next one. Now, this one starts at the top. So I know if it starts in the middle, it's going to be sine, but because it starts at the top, this must be a cosine graph, which means my end result is going to be y equals something cosine of something x. Let's take a look. So when does this graph reach at the top again? Looks like at 2 pi. So for my period, I know if it's normally 2 pi divided by b and the result is 2 pi, well, then that number is going to be 1. But let's go ahead and work out the math. So I'm going to cross multiply. Get 2 pi equals 2 pi b. Divide both sides by 2 pi. I'm going to get b equals 1. So I know it's just going to be a 1x right in there. My amplitude, again, is how high and how low does the graph go? Well, it goes up and down to 4. So my equation, I'm going to reduce this a little bit, is y equals 4 cosine of x. That's it. Let's do 2 more just to be sure. So with this one, it starts in the middle. I know it's a sine graph, and I know it repeats every 4 pi, because by the time it gets back to its starting point, it's over there. So for my period, 2 pi divided by b ends up giving me an answer of 4 pi. Cross multiply, so 2 pi equals 4 pi b. Divide both sides by 4 pi. and I get, that looks like 1/2 is equal to b. So y equals sine of 1/2 x. That's my b value right there. For my a value, I just see it goes up to 2 and down to -2, which means my amplitude is 2. Or y equals 2 sine 1/2 x. Oh. And so the last section, we notice it starts at a peak or a trough, so this must be a cosine graph. Let's go ahead and figure out how this goes. Well, the period normally would be 2 pi over b, and I notice that it repeats itself at 2 pi. Again, this is going to be a 1. So I get y equals cosine of 1x. Tried to underline the wrong spot there. The last thing that we're going to do is we're going to notice, hey, unlike the one previous where we started at the top, this one we started at the bottom. So our amplitude, instead of being a +5, it's just going to be a -5, which means y equals -5 cosine of x. That's it. For this section, what we're going to be doing is finding the period and the amplitude given just the equation, because the idea is we want to eventually be able to graph these, so I need to know the period and the amplitude. So for sine, I know the period is going to be 2 pi divided by b, which is 4. And I'm just going to reduce that, which ends up being pi over 2. And that's my period. For the amplitude, it's just that number out front, which is going to be a 1. In fact, all of these for my amplitude, it's going to be that number out front. And so you can just look at the equation and figure out what it's going to be. Without doing any math, you're just writing down the number. That's going to be how high and how low does the graph go. So for this one, I know that my amplitude is going to be 2 because of that number out front. The only math I need to do is figure out how long does it take for the graph to repeat itself. Well, 2 pi divided by -2, that would be a -pi. For this sine wave, I know the period is going to be 2 pi divided by 2/3, or what I could do is keep change flip. 2 pi times 3 over 2, which is 6 pi over 2, or just 3 pi. And we know the amplitude is that number out front, which is 3. Same thing for cosine. For cosine, the period is going to be 2 pi divided by 0.3. And I'm going to make this a little easier because I'm dealing with a fraction and a decimal, and I can't have both those in the same thing. So what I'm going to do is I'm going to change this to a 2 pi over 3/10, which is the equivalent of that decimal. So let's take a look. 2 pi times 10 over 3, or 20. Okay, so this is going to be one iteration of 60 degrees. So it's going to be a lot easier to graph having turned this into a fraction. Now the amplitude is that number out front, which is a 1. For here, my period is going to be 2 pi divided by -3, which is fully reduced. Can't go any further than that. My amplitude is just going to be 3. Here, my period, 2 pi divided by b, which is pi. Ooh, so I get a period of 2. Much easier to graph. The amplitude is 4. And so that mostly is what we're going to be doing, is sine and cosine. Take your period, 2 pi divided by the b. The amplitude is the number out front. The only difference with tangent is that instead of saying 2 pi divided, we know the period repeats faster, so it's going to be pi divided by 2, which doesn't reduce. The amplitude is still the number up front, which is 1. Here, the period, instead of being 2 pi, is going to be pi 1/2. That's a 1/2 if you believe it. We're going to keep change flip that. Pi times -2/1, which is just a -2 pi. The amplitude is the number up front, which is 5. And so we see as we work these, it's a very repetitive pattern. All of these repeat themselves. In this case, because it's x divided by pi, I'm going to imagine a 1, and that's actually a 1/pi. So I can keep change flip that. So pi times pi/1, which is pi squared. The amplitude is 8. There we go. So this section is where we bring it all together. We're going to be stating the period and the amplitude of each one of these sine and cosine waves, and then we're going to be using that to actually graph the waves. So let's take a look at the first one. The first one is y equals the sine of 4x. I'm going to go ahead and find my period and my amplitude. My amplitude is the number up front. It's going to be going up to 1 and down to -1, so I know it's not going to be moving too much. I know the sine wave also starts in the middle, it goes up, comes down, and it comes up again. So we're going to be seeing that shape first. So let's take a look at the period. It's 2 pi divided by 4, or every pi over 2 units. So if we do every pi over 2 units, I know that my graph is going to repeat itself every time it hits here. So it's going to go up, down, up, up, down, up, every 2 blocks by the looks of it. And it's going to repeat itself going backwards every pi over 2 units. And so if I go up and down and up, I know I'm going to be crossing through right here. But it's going to reach its peak here, and it's going to reach its trough here. So I'm going to get up, down, up. And I'm going to repeat that. So it looks like in the first block is when I hit that top point, and in the second block is when I hit that bottom point. So top, bottom, top, bottom. And I'm just going to curve through all of these points. That's my sine wave. And going backwards, I'm just going to repeat. Just as going the other way. So I'm going to hit my bottom in the first block and my top in the second block. Bottom, top, bottom, top, bottom, top. And then I just curve between the two. Boom. And there's your first official sine wave. So let's take a look at a cosine wave. Now the only difference with a cosine wave is we start at the top and we curve our way down and then come our way back up to the top. So albeit it's going to have the same shape as this, we're going to start at a different point. So if we find our period, there's no number here, so it's just 2 pi. Our amplitude this time is a little bigger. It has an amplitude of 3. So if I start at my top, I know at the very beginning I'm going to be at 3. And every 2 pi units, I'm going to be back up at the top. Or every 2 pi units, I'll be back up at the top. Which means directly between those points, I'll be at my bottom value. Or directly between 0 and 2 pi is pi. I'll be at the bottom. Directly between 0 and -2 pi is going to be pi. And I'll be at the very bottom. And all I'm going to do is I'm going to curve between those points. we have our sine wave. If you extend it out backwards, you just curve it between those points. There we go. And that's our first cosine wave. Let's take a look at the bottom two. Bottom two are done the same way. We just have two different aspects. I know I'm going to have an amplitude of 3, and my period is going to be 2 pi divided by 1/2. If I keep change flip, times 2/1. So I'm going to have a period of 4 pi, which my graph only goes to 2 pi, so I'm not going to get a full interval. I'm not going to get a full period. I'm only going to see part of it. Let's take a look at which part. Well, if the sine goes up, comes down, and then repeats itself right there, I'm only going to see the first half or the top of that wave. So let's take a look. I'm only going to see the first half, so halfway is going to be at 2 pi. So it's going to curve its way up, and I'm not going to see the bottom of the curve. And it's going to go all the way up to 3. So I'm going to see it curve up, come down, and if the graph was bigger, I would see the second part of that wave. But it's not, so I don't see it. Now let's repeat it back going the other direction. And directly halfway, it's going to receive its minimum value. It's a little bit too curved, but you get the picture. And now we would normally see the second half of that wave if the graph extended further. It doesn't, so this is going to suffice for our sine wave. Last one, cosine. So cosine, we know we have a period of 2 pi divided by 4, or every pi over 2. It's going to be repeating quite often. And our amplitude is every 1.5. And again, we know a cosine wave starts at the top, curves its way down, and then back up. It's got the same overall shape. It's going to start at a different point. So let's go ahead and let's start at the top of our graph. And I know every pi over 2, it's going to hit that top point. So every 2 blocks, it's going to hit that top point, which means every block, it's going to hit that low point. And then all your job is to curve between the 2 of those. And so again, every 2 blocks, it reaches the top. And in between those, it reaches the bottom. And your job is just to curve. Maybe not so wibbly wobbly as mine, but just curve between the 2. And there we go. And that's graphing your cosine function. Okay, so we saw the fact that using those two features, the amplitude and the period, the amplitude being how high and how low does the graph get, the period over what span does the graph repeat itself, we can graph any sine or any cosine function. We will eventually graph tangents, but that's not going to be in the scope of this course. That will be for a future course. So if you have any questions, let me know.